Hello and welcome back. So we're going to look a little bit about solubility and the dissolving process in this lecture. So what exactly do we mean by solubility? So solubility is some kind of measure of how much solute you can dissolve. In a particular amount of solvent. We'll see that we can use some qualitative words and we can also use some quantitative terms here in this section. So that is solubility. In fact, there's a very similar term called miscibility, and miscibility refers to the ability of liquids and liquids to mix, and solubility refers to the dissolving of anything else, so a solid in a liquid, or a gas in a liquid, or solid in a solid, and so on. So miscibility is one of those things. So for instance, if you're mixing ethanol and water to make vodka, then you would refer to the miscibility of ethanol in water. But if you were mixing, say, sodium chloride, which is a solid, in water, then you would start talking about the solubility. And likewise, if you were taking, say, carbon dioxide in ethanol, you would be talking about the solubility of that gas too. So miscibility, I'm not sure why miscibility refers to liquids and liquids, but everything else is referred to as solubility. Let's briefly examine the solubility process. So essentially what we have are two components here. So the red is going to be my solute particle, and the blue is going to be my solvent particle. So I don't know, red and blue, why not? Sounds good. And we're going to go ahead and mix one into the other. So we're going to start off with a beaker of solvent. So we've got solvent, 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 solvent. So it looks very blue and spotted. And what is holding those solvent molecules together? Those are the intermolecular forces. So we've got some kind of interaction between the liquid molecules that are holding them together, right? Otherwise they'd be a gas. And there we go. And so this is my solvent. Okay, and I'm going to go ahead and I'm going to take a beaker of my solute, and imagine it's a liquid, right? It could be a solid, doesn't really matter. And so I have some particles here, and they are happily stuck together, right? Unless it's a gas, but that's another story. And we are going to pour one into the other. So essentially we're going to pour the solute molecules into the solvent. And the question is, do they dissolve, right? So, or if they're liquids and liquids, are they miscible? So what has to happen if they dissolve, right, is the solute particles have to kind of move in between the solvent particles, right? And I probably have the wrong number here, and it's going to look something like that when we are said and done. And what are we doing here? Well, now we have to have interactions between the solute and the solvent, whereas before we just had interactions between the solute and the solute, and the solute and the solvent and the solvent. So we are essentially replacing, okay, some of these interactions that we had before. So this is what we have to really decide, right? So we have to presumably break some of these interactions here and break some of these interactions here and replace them with these new ones, right? So we are essentially breaking some solvent-solvent and solute-solute, and we're replacing them with solute-solvent. So let me write that down. Okay, and now we're forming these new ones, right? We are forming essentially solute, solvent, intermolecular forces. So in order for something to dissolve, essentially the amount of energy it takes to break these and these should be hopefully comparable to the amount of energy you get when you make these. So essentially you're breaking some old ones and you're replacing with new ones. And as long as the new ones are as strong as or stronger than the old ones, then we would imagine something would dissolve. Now, what happens if they're not? So what happens if these are strong and these are weak? Well, they probably won't dissolve, right? So the solute is not going to say, well, I'll break my intermolecular forces and form these wimpy ones, right? I mean, that's like saying, well, I'll give you a $50 bill and you give me a $10 bill, right? No one wants to do that. But, you know, imagine I give you some crinkly $10 bills, right? And I replace them with some nice shiny $10 bills, or even $10 plus 50 cents. You'll be like, yeah, that sounds like a pretty good deal. So in order for something to dissolve, the intermolecular forces we break have to be replaced by forces that are as strong or stronger. So a little more to it than that. That's a pretty good way to think about dissolving.